Hello, we are discussing about GATE 2004 ECE paper, and this question is related to the electronics. Assuming that beta of the transistor is extremely large and VBE is zero point 0.7 volts, IC and VCE are in the circuit shown R. So what are the values of IC and VCE for the circuit given if beta is very large and VBE is zero point 0.7 volts? The meaning of beta is very large. Beta of the transistor is very large is nothing but, if you are going to calculate IB, how do we calculate IC by beta? So if it is beta is very large, IC by very large, that implies nothing but IB is negligibly small, so you can assume it as 0. So the meaning of beta is extremely large is nothing but IB can be neglected. Simply the other way of specifying is IB is 0. So there is no current is flowing through this one. IB is equal to 0. So that here what you will get is nothing but IE, emitter current. Emitter current is sum of base and collector currents. But emitter current is also equal to collector current since IB is equal to 0. So the same collector current whatever flowing through in this resistor, the same is going to be flowing in 300 ohm resistor, that is IC. Okay, and no current is flowing into base, so that if any current, whatever the current flowing through this 4 kilo ohms, okay, that also flows through this one. So if you assume this is going to be I1 at that time, the current flowing through 1 kilo ohm is also I1. So we can use a voltage division rule to calculate the base voltage. Now we will see how to calculate IC and VCE over here. So here first of all IB is equal to 0, and this we can write it as a simplified diagram with by applying Thevenin's theorem. By that time we can draw a circuit like this. So at base we are applying Thevenin's theorem, so that it is plus 5 volts and it is RC, the current flowing through is IC, same current is flowing through this one which is also IC, and it is 300 ohms, and this value is RTH, Thevenin's resistance, which is nothing but 4 parallel 1, and Thevenin's voltage VTH. Okay, VTH is equal to, we can write it as voltage drop across 1 kilo ohm is nothing but VTH. Using voltage division rule you can get voltage across this one as 1 by 1 plus 4 into 5. So 1 by 5 is nothing but VTH, you will get it as 1 volt. 1 volt is the voltage, and this is the VBE if you are going to indicate base to emitter voltage plus minus. Okay, and current flowing through this one is nothing but IB. Apply KVL at base emitter loop. So by that time VTH minus IB times of RTH minus VBE minus IC times of RC, that is nothing but 300 ohms, is equal to 0. VTH is 1 minus IB is equal to 0, so that term will not appear, and VB is given as 0.7 minus IC times of 300 ohms. So IC is equal to, from this one, 0.3 divided by 300 ohm, which is nothing but 1 milliampere. IC is equal to 1 milliampere. Okay, next we are going to calculate VCE. So here it is, the resistor value it is not indicated, so this value is going to be, it is a printing mistake, which is 2.2 kilo ohms. It was given 2.2 kilo ohms. So 2.2 kilo ohms is the RC value. By applying KVL across collector emitter loop, you can calculate VCE. So apply KVL, plus 5 minus IC times of 2.2 minus VCE minus IC times of 0.3. 300 ohms can be written as 0.3 kilo ohms. Kilo is going to be neglecting, is equal to 0. and 5 minus IC is 1 milliampere. 1 into 2.2. 2.2 minus 2.3 is nothing but 2.5 minus VCE is equal to 0. So VCE value is nothing but 2.5 volts. 2.5 volts. 5 minus 2.5, which is nothing but 2.5 volts. IC is 1 milliampere. VCE is 2.5 volts. Okay. So the right option for this one is nothing but C. IC is 1 milliampere. VCE is 2.5 volts. Thank you.